Bismillahirrahmanirrahim. Assalamualaikum and hello everyone. My name is Dr. Noatika Nasir. Thank you and I appreciate your time for watching and listening this recorded conference. First of all, I would like to thank you to all 2020 KoSiST 2020 committee for organizing this event, and I believe this is such a good platform in sharing, gaining and exchange the information among the researcher. My presentation today is about converting the biomass waste into such a potential product called bio-oil. The method that I'm focusing in current research is by using hydrothermal liquefaction method. So this is roughly what the presentation today about. I will start with the introduction, which will define the biomass in general, and also what is brewer's spin grain, the starting material that I'm used, and the method that we'll choose to convert this biomass, followed by the research framework in general, and then focus on the characterization results and also one of the preliminary studies conducted, which is we try to compare the direct and pre-treatment method. And at the end, we come to the conclusion for the result finding. Okay. Okay, for the introduction, to overcome the global crisis on fossil fuel depletion, researchers introduced alternative energy. Then, the term biomass have been such a trending word in solving the issue. Biomass can be used to produce fuel for energy, chemicals, and materials. Okay, biomass feedstock can be converted into various products by using thermal processes, chemical processes, and biotransformation. In current work, my research are using industrial waste, which is brewer's spin grain as a biomass feedstock, to produce bio-oil by using hydrothermal liquefaction. So, what is brewer's spin grain? BST. BST is a byproduct in the beer production. At the final stage in the beer brewing process, the sweet wort will fermented to produce beers. Meanwhile, brewer's spin grain is left as a byproduct. And it should be noted that for every 100 liters of beer being produced, there are 20 kilos of this waste are generated. So, as the demand for the beer is continuously growing, many concerns been raised about the impact of this waste, and then current solution or current action be taken for this waste is just either sent to landfill or used as animal feed. Okay, however, the percent usage of the waste is not more than 30%. So there are a lot of things that need to be think to remove or to utilize this waste. Okay, on the bright side, since is a BSG is a biomass, so it's contain a valuable chemical composition on it, and it is in low cost and large availability. Okay, in the introduction part, I already said that the process chosen for current work is liquefaction, and since I'm using water as the reaction medium, we call it as a hydrothermal liquefaction. Then, why water? Okay, water is one of the most plentiful compound in the universe, and utilization of water offers such a sustainable and cheap option process. Okay, as you can see in the diagram, the liquefaction takes place in the blue region, and since the reaction conducted at the region, it offers the lower dielectric constant value or polarity, which increase the solubility of the reaction media and biomass. The second point is the increase in ionization constant, which promoting the release of hydrogen and hydroxide, or can act as an acid or base catalyst reaction. The combination of this hydrothermal liquefaction to break down biomass for me is such a great combination, as it offers a really reliable method, cheap and effective. Okay, here is the full research framework that conducted in current research. We start with the characterization to determine the moisture content and chemical composition, followed by preliminary study on hydrothermal liquefaction by using two methods. Either we using raw BSG, which is direct reaction of HCl, or we dry the BSG and then using water as a pure water in the reaction media. Okay, here is a characterization of BSG, and from the extraction it shows that BSG contain the cellulose, hemicellulose and lignin, which is a raw material and potential for production of biofuel, mainly bioethanol. However, as we can see from the graph, the moisture content in this BSG waste represent about 3/4 of this raw waste. Due to this, any application using BSG as a feed source need to consider the best way to handle the moisture content. As my proposed method is hydrothermal liquefaction, which is I'm using water as a reaction medium. So it is really interesting to know how this moisture content in BSG act in the reaction. To have a look on how the moisture content in the BSG affect the hydrothermal liquefaction, we compare two different system, which is the first one is direct HCl versus pre-treatment. All the parameters are the same except one of the BSG been dried up and then one of the BSG been the other system is directly introduced the raw BSG. And it is interestingly to note that a slightly higher conversion obtained in the direct HCl system as compared to the pretreatment. The difference for conversion is about 4.5%. Meanwhile, the oil produced also better in the direct HCl by difference of 2.1%. Okay, this is might be due to the fact that raw BSG possess the high humidity and fermentable sugar content help in lower the reaction medium to take place. The GCMS analysis also conducted, and it is interesting to have a look that both chromatogram, either you are using pure water or direct HCl, which is the waste being introduced to the reaction directly, have the same or almost similar pattern, and we try to have a concentration of the liquid obtained, and it showed that most of the main product were dominant in direct HCl. So, as a conclusion, the characterization contribute to a significant understanding in directing the reaction or indicating the possible route for their utilization. Second is current findings show that hydrothermal liquefaction, which is by using water medium, it is able to convert BSG in producing useful chemical and valuable product, which is we able to produce the bio oil. And then the final one, which is the main findings, is direct HCl system produce better conversion, water soluble oil yield and product concentration, which mean it provide the best platform to utilize the BSG with the high moisture content without need for any pre-treatment process. Okay, so before I end the presentation, I would like to say thank you to Faculty Science and Technology team. Thank you to my supervisor, Dr. James McGregor. So basically, this research conducted during my PhD period, which I really thankful to my research group, Sheffield Catalysis Group. Thank you.
At first, take my salam. Assalamu alaikum. This is Shahin Azad. I am a PhD student of FST faculty at UC. My supervisor name is Associate Professor of Dr. Mohammad Shukri Hassan. I would like to discuss about my presentation. My presentation title is Removal of Methylene Blue Icerasa coli and Pseudomonas aeruginosa by adsorption process of activated carbon produced from Moringolephera bark. Now I want to discuss about my introduction. Moringolephera is a commonly known as multipurpose domestic tree. It is available in Southeast Asia, Africa, and South America. Moringolephera bark have a non-toxic natural organic polymer such as alkaloids, phenols, glycosides, which have been employed as an effective solvent for removal contaminants from wastewater. Different studies have showed that various parts of Moringolephera, such as stem, flowers, bark, roots, as well as seeds, have removal ability to eliminate dye, bacteria, and pollutant from wastewater. So it is very important for research. Water is the biggest component in the Earth's surface that is used for several goals by living organisms and agriculture. At present, 1.1 billion people don't get to use fresh water, and 2.6 billion general public are uncovered with sanitation facilities. Some common methods used for removing dyes from wastewater are ion exchange, absorption, precipitation, and membrane separation. Among those processes, absorption is one of the efficient method to remove contaminant from wastewater. Absorption process is a promising method because of its simplicity and well effective compared to others methods. Now I'd like to discuss about background. Wastewater discharged by industrial activities, municipal activities, hospital waste, household activities, etc. are often contaminated by toxic substances which have a negative effects on all animals. Nowadays, the level of purity of water being decreased and it is very risky that could affect our health due to disease like gonorrhea, worm and bilharzias. The common methods used for wastewater treatment are restricted because of technical problem produced more sludge disposal and financial barriers. Agricultural waste materials is a cost-effective absorbent and easy to handle disposal problem. It can solve disposal problem of agricultural waste by converting to activated carbon. Now I want to discuss about literature review. Moringolifera as well as medicinal plant can be used as an absorbent and coagulation. Various parts of Moringolifera such as stem, bark, roots have antibacterial activities, have reference. Mostly 50% of total dyes is released from textile industry. Nowadays synthetic dye controls most of the chemical industries, have reference. Methylene is a basic dye which is heterocyclic aromatic compound. It has many positive and negative applications such as irritation of mouth, throat and symptoms of jaundice in humans, have reference. Definition of wastewater. Wastewater is unwanted and unrecovered substances in waterborne waste released from domestic, industrial, and unknown sources. For example, wastewater contains detergent, oil, suspended solids, sewage, bacteria, toxic metals, dyes, and etc. Major types of wastewater. There are three major types of wastewater in the environment: household wastewater, industrial wastewater, hospital wastewater. Household wastewater contains pollutants like oxides of salt, detergents, suspended particles, color, dyes, oils, grease, etc. Industrial wastewater contains nickel, chromium, copper, zinc, lead, silver, cyanide, soaps, oils, hydrogen sulfide, ammonia, and grease, and also suspended solids. Another side, hospital wastewater contains poisonous blood, anatomical waste, cultures, unnecessary medicines, chemical waste, body fluids, and human excreta. Now I'd like to discuss about problem statement. Water is important for human, animals, plant, but nowadays the water is contaminated by many sources such as household, hospital, and industrial waste water. In hospital, during diagnosis and dealing of patients, various waste are generated which could be infectious, toxic, dangerous. Contaminants enter into water system can cause human cancer of breast and skin. Generally, commercial activated carbon is used as absorbent in an absorption process due to high capacity, environmental friendly and non-toxic. But it is costly process, and the third world countries could not afford for the high cost. Researchers are now looking cheaper technology as alternative option from natural products which are absolutely halal for the wastewater treatment. Many natural plants had been used as absorbents for the removal of dyes and heavy metal from wastewater, such as oil palm, granite shell, and monocultural leaf have reference. However, no research has been conducted on the efficiency of the activated carbons produced from monocultural bark on dyes and bacteria both at the same research. Now we'll have to discuss about major classification of wastewater treatment. There are six major classification of wastewater treatment. Number one, chemical precipitation. Number two, ion exchange. Number three, electrodialysis. Number four, reverse osmosis process. Number five, coagulation, flocculation, and number six, adsorption. Adsorption is a process that occurs when a gas or liquid solid accumulates on the surface of a solid or liquid, forming molecular or atomic film. The exact nature of the bonding depends on the details of the species involved, but the absorbed material is generally classified as exhibiting physiosorption or chemisorption. There are have many advantages and disadvantages of wastewater treatment. First, chemical precipitation. The large amount of sludge containing toxic compound produced during the process is the main disadvantage. Ion exchange. A noticeable disadvantage is that corrosion could become a significant limiting factor where electrodes would frequently have to be replaced. Electrodialysis disadvantage. The disadvantage is the formation of metal hydroxide which clog the membrane. River osmosis process. The disadvantage of this method is that it is very expensive. Coagulation flocculation. In spite of its advantage, coagulation flocculation has limitation has high operational cost due to chemical consumption. But absorption is the most cost-effective treatment method for removal of pollutant from wastewater by low-cost absorption like Moringa or Dramastick. There are two types of absorption. Number one, physical absorption. Number two, chemical absorption. What is physical absorption? Intermolecular forces of fascination between molecules of the solid absorbent and the substance absorbed is called physical absorption. It is a reversible absorption. Another side, chemical absorption. What is chemical absorption? Chemical interaction between the solid absorbent and the absorbed substance is called a chemical absorption, but it is a irreversible absorption. Now to discuss about objectives of the research. The proposed research project was undertaken with the following objectives. Number one, to prepare activated carbons from the waste agricultural products of Moringa bark. Number two, to evaluate the absorption efficiency of prepared activated carbon on methylene blue dye and bacteria spike in an aqueous solution. Number third, to characterize the high efficiency of activated carbons in B using FTIR, bait and SEM. Methodology of the activated carbon. First, I collect 200 gram per sample collect from the natural sources, then sun dry and washed with distilled water, then dry in oven and 110 degrees centigrade for 12 hours, then grinding with blender or mortar and parsley, and then chemical activated with zinc chloride and sulfuric acid ratio at 1:5 for 12 hours, then dry in oven again at 110 degrees centigrade for 12 hours, then crushed and shaped at 200 micrometer to 400 micrometer, then placed in the furnace at 700 degrees centigrade for 60 minutes due to the carbonization of the raw materials. Then sample was soaked in the 500 ml 0.5 molar hydrochloric acid for 1 hour due to remove the calcium oxide. Finally, then washed and dried, then saved and activated carbon is stored in polypropylene bottle to avoid the moisture. Methylene blue unactivated carbon wastewater. Natural products have glucosinolates and phenolic compounds. Every glucosinolate has a central carbon atom which is separately bonded to thiglucose group and sulfate group. Absorption of methylene blue ion occurs as a result of physiochemical interaction, mainly ion exchange or complex formation between methylene blue ions and the functional groups present on the cell surface. There are four main stages in the process of absorption by process absorbents. Solute transfer from the bulk solution to the boundary film that surrounds the absorbent surface. Solute transport from the boundary film to the absorbent surface. Solute transport from the absorbent surface of activated interpol sites. Lastly, interaction between the solute molecules and the available absorption sites on the internal surface of the absorbents. Mechanism of the reaction. Characterization of activated carbon. Figure shows the FSM micrograms of the Moringa bark activated carbon before absorption under 60 magnification and 500 magnification. Large and well-developed pore are obtained from prepared activated carbon under optimum condition. The largest pore was the surface area of 435.1738 and pore volume was 0.189245 centimeter cube per gram. The development of surface quality of absorbers can be occurred due to the elimination of impurities from surface using acid. FTIR spectrum of Moringa bark shows the characteristic of peaks obtained with slightly shifted after absorption, but it was more intense peak. The peaks were detected at 3371 centimeter per centimeter for hydroxyl group. The presence of oxygen functional group peak was detected at 1126 per centimeter. It could be indicated as the polarity. Now I'd like to discuss about the resultant discussion. Langmuir, Freundlich, and Dominin radioscopic isotherm. From the table, Freundlich model closely fitted with data. The symbol of B is designated for the absorption affinity of activated carbon. Qmax is considered as the total active parts of the absorbents, but Q is defined for the binding parts which are filled up by solute. The theoretically Qmax for Moringa is found to be 129.87 for methylene blue ions. That is not comparable with experimental calculated Qmax 108.12. On the other hand, constant symbol K is designated the strength of absorption. Lower value of K indicated the more absorption. Data would be favorable when n value is 1 is less than n is less than 10. All data of Moringa was well fitted of Freundlich system with coefficient regression. Now, kinetics of absorption. There are far difference for QV values between experimental 108.12 and calculated value 232 for first order equation. So this graph was not fitted with first order model. On the other hand, the experimental value and the cumulative value are closed for a CVT second order model with coefficient correlation constant. The results indicate that there are several steps involved in absorption process. The rate of absorption for methylene blue are evaluated by external transport or internal transport. Most of the line developed did not pass through the origin as shown figure third. It is indicated that the absorption process was controlled by film diffusion. So the absorption methylene blue by Moringolifera were conducted by film diffusion then internal transport. Effect of initial concentration. With increasing the initial concentration, the removal percentage of methylene blue from aqueous solution was decreased, but the absorption capacity of absorbents also increased. At lower initial concentration, that means 5 milligram per liter, about 94.2% of methylene blue was removed, and with increasing the initial concentration up to 50 milligram per liter, the removal percentage of methylene blue was above 50%, and the absorption capacity was about 108 milligram per gram. It can occur due to passes high of surface area and active functional group onto activated carbon. The higher mass transfer of absorbance was due to the increase in the driving force, which was the initial concentration of dye. Effect of doses. From the figure, the removal percentage increased from 25 to 100% for methylene blue, with increasing the absorbent dose from 0.005 to 0.05 gram. It was removed 94.2% from aqueous solution for using 0.025 gram of activated carbon, that means 25 milligram. It can be occur due to available active sites present on activated carbon for absorption. Further increasing the absorbent dose, the removal percentage was not significant. This may be happened due to reach the equilibrium state between binding absorbate and unabsorbed absorbate in absorption process. The removal percentage of E. coli were obtained 29.3%, 62.7%, and 87.8% respectively using on 35 milligram activated carbon of Meningolifera but at 37 degree for 1 hour. On the other hand, the removal percentage of pseudomonas incubated with on 35 milligram absorbents were obtained 59.8%, 74.1%, and 90% respectively. E. coli was decreased as 98%, and pseudomonas was reduced 96% using 10 milligram of absorbents. Effect of pH. The absorption mechanism of methylene blue can be conducted by the electrostatic force. With the increasing pH value, the concentration of hydrogen ion in solution decrease. The negative surface charge will be an increase on the activated carbon above the pH value of 5.4. For this reason, absorbers can more attract as the cationic form of methylene blue. It can easily absorb onto absorbers. The methylene blue can be also absorbed on absorbers by ion exchange mechanism. The main functional groups of absorbers are the carboxylic, hydroxylic carbonyl, methoxyl group. All are responsible for ion exchange on to their surface at appropriate pH. At pH 6, the absorption of methylene blue was maximum. At time. The absorption of methylene blue by Moringolofera bark was increased with time up to 80 minutes. Then it became constant at the end of the experiment on 120 minutes. It suggests that the metal binding rate of absorbance was more during initial stage. After some time, gradually increased and remains almost constant after 82 to 120 minutes. When the dye was contracted with active sites of absorbance, then it involved soon in cation complexation. The 5 milligram of absorbent was incubated with 1 milligram of E. coli and Pseudomonas during 10 to 60 minutes. However, binding activity of activated carbon with E. coli and Pseudomonas has been increased with increasing the time. After reaching 40 minutes, the removal percentage of bacteria did not show more significant. The number of bacteria using this method. From the table, the number of bacteria were counted on 120, 55, 5, and 0 for E. coli using 1 milligram, 3 milligram, 5 milligram, and 10 milligram activated carbon respectively, and 165, 145, 95, and 0 for Pseudomonas aeruginosa bacteria using activated carbon of Moringolifera respectively. I would like to discuss about conclusion. The absorption of methylene blue using the activated carbon of Moringolifera was closely fitted by Ferrolic model. The methylene blue absorption of activated carbon were showed physical absorption by DR model. The absorption kinetics parameter were well fitted by pseudo second order model, then pseudo first order model, and intraparticular diffusion. The increase in dose of activated carbon enhanced the actual absorption capacity, and at 10 milligram of absorbance, it shows maximum absorption capacity of 98% for E. coli, 96% for Pseudomonas, as well as 94.2% removed methylene blue using 25 milligram activated carbon. The results suggest that the activated carbon of Moringolifera can be used as a good absorbent to remove contaminant from wastewater. Here I discuss about references. Here total 16 references have uh, many slide already discussed about this reference. Finally, thank you very much to all for giving me chance to deliver my presentation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Isnurimitul Muhammad Riza and I'm from College Chinese Insan. Today, I will be presenting my research entitled Comparison of Antioxidant Compounds between Glycine Max and Bostaurus Mux. My presentation today will be covering an introduction, experimental methodology, results and discussion, and conclusion. As for the introduction, soybean or glycine max is one of the most consumed plant-based resources with 200 million metric tons produced per year. The usage of soybean has been widened with the production of various products such as soybean powder, soybean milk, and soybean oil. It is due to its cholesterol and lactose-free. Moreover, soybean has significant amount of saturated fatty acids, antioxidant compounds, and different phytochemicals with beneficial properties. Cows, or its specific name, Bos taurus, is a domestic mammalian which known as the main sources of milk and dairy products. Cows were first domesticated as all-purpose animal as it can be used as draft animals and also for the production of milk and meat products. Moreover, cows are also used by humans in many other ways, such as the source of leather for clothing and other products. Dairy products that were produced by cows, especially milk, contains many bioactive components that boost the physiological processes in the body. As for milk, milk is an essential source of nutrients for human consumption that were derived from animal and plant-based such as cows and soybean. Types of compounds that were normally found in the milks are consist of carboxylic acids with a long aliphatic chain. The benefits that we could get by consuming milks in our daily life is that it has antioxidant compounds that plays an important role in neutralizing free radicals in human body. Besides, it also promotes healthy functioning of brain, nervous system, and sleep-wake cycles. There are three main objectives for this research. Firstly, to extract antioxidant compounds from soybean milk and cow milk using liquid-liquid extraction technique. Secondly, to investigate the functional groups that were present in the soybean milk and cow milk samples from the spectrum obtained by attenuated total reflectance Fourier transform infrared. And lastly, this research was carried out to compare the antioxidant compounds in both milks. As for the methodology, firstly, the milk samples, which are greenhouse soybean milk and farm fresh cow milk, are measured in measuring cylinder. Then, 20 ml of each milk are poured into two separate conical flasks. 20 ml of ethyl acetate are also added into each milk samples. The mixture in the conical flasks are then sealed with parafilm to prohibit foreign substance from mixing with the milk samples. All the conical flasks were labeled and samples were left in the chiller for 24 hours. On the next day, all milk samples were extracted by liquid-liquid extraction technique using separating funnel. The samples are poured into separating funnel slowly. Then, two layers, which are white layer containing water molecules and the remaining chemical compounds of the milk, and a transparent layer containing extractable compounds, were created by the mixture of the milk samples and the solvents. This procedure has been done twice to optimize the compound's extraction. The excess solvents are then removed by using rotary evaporator in which the bath temperature for milk sample with ethyl acetate were set at 76 degrees Celsius. The extractable compounds that were left in rotating bottle were collected and stored in sample bottles. The sample bottles were then left aside in a chiller for a few days. The samples that were chilled are then tested with the attenuated total reflectance Fourier transform infrared machine to collect the data of its frequency and spectrum. Thus, with that, functional group of the milks can be identified to determine the antioxidant properties present in both milk samples. For the results and discussion, this first figure shows the ATR-FTIR spectrum of greenhouse soybean milk sample that were extracted with ethyl acetate. For the first peak, the transmission measurements are attributed to phenols as due to the OH stretching bond. For the second peak, the transmission measurements are attributed to amide as due to the NH bending. The transmission measurement at this peak also attribute to amide due. Besides, alkenes are attributed by the transmission measurement at this peak due to the presence of double bond CH bending. Figure 2 shows an ATR-FTIR spectrum of farm-fresh cow milk samples that were extracted with ethyl acetate. The transmission measurement at the first peak attribute to phenols due to its OH stretching bond. For the second peak, the transmission measurement attribute to amide due to its NH bending. The transmission measurement at this peak also attribute to amide due to its CO stretching. Meanwhile, at this peak, the transmission measurement attribute to aliphatic amines due to its CN stretching. Figure 3 shows an overlay ATR-FTIR spectrum of greenhouse soybean milk and farm-fresh cow milk samples that were extracted with ethyl acetate. The transmission measurement at the first peak of both milk samples shows an almost similar value. The transmission measurement at this peak attribute to phenols as due to the OH stretching bond. For the second peak, the transmission measurement also shows an almost similar value. The transmission measurement here attribute to amide due to its NH bending. Meanwhile, at this peak, the transmission measurement attribute to amide due to its CO stretching. And the transmission measurement at this peak attribute to aliphatic amines due to its CN stretching. As a conclusion, soybean milk and cow milk were studied to investigate the antioxidant properties of their major functional groups. Second, soybean milk are believed to have similar antioxidant compounds due to the similar peak obtained from the attenuated total reflectance Fourier transform infrared ATR-FTIR spectrums. And lastly, this study provides the data from the analysis of ATR-FTIR spectra of soybean milk and cow milk samples. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Raja Nurul Ashikin binti Raja Arifin, and today I'm going to present my research entitled Antioxidant Activity of Averrhoa bilimbilin leaves using two types of solvents. Increase in number of vehicles, urbanization, industrialization, and domestic combustion of organic materials has led to air pollution. Air pollution is one of the world's largest health and environmental problems. Indeed, WHO estimates that around 7 million people die every year from exposure to polluted air. Air pollution promotes the generation of reactive oxygen species, which is ROS, by penetrating deeper inside human skin. Excessive ROS can cause skin disease such as skin aging, inflammation, melanogenesis, and also skin cancer. So how to prevent this problem? We can prevent this problem by using antioxidant. What is antioxidant? Antioxidant is a molecule that can inhibit the reaction of free radical from ROS by donating its electron. Since 20th century, the attention of seeking natural antioxidant is increased because natural antioxidant is considered safe, biodegradable, environmentally friendly, and also low cost. It is also contains of many bioactive compounds which can pose as antioxidant. So, in this research, I am going to use the Averrhoa bilimbilin leaves. Averrhoa bilimbilin leaves is one of the example of natural antioxidant. This plant extract belongs to the group of Oxalidiaceae and it is normally can found in Malaysia. It is also consists of phenols, flavonoids and tannins which can act as antioxidant. Air pollution, as we know, it is generated ROS, harmful to human skin, cause skin disease by penetrate deeper inside into human skin. So, objective of this study is to extract the Averrhoa bilimbilin leaves using two types of green solvent, which is ethanols and water. Second, to identify the total phenolic and also the flavonoids content. Then lastly, to determine the antioxidant activity of Averrhoa bilimbilin leaves extract. Here is some of example of previous study on Averrhoa bilimbilin fruit. Here is some of example of previous study on Averrhoa bilimbilin fruit. And also previous study on Averrhoa bilimbilin leaves. And also previous study on Averrhoa bilimbilin leaves. This study, I'm extracting the plant extract using two different solvents, which is ethanol and also water. The second step is determination of bioactive compounds, which is determine the phenolics and also the flavonoids compound. The third step is to test the antioxidant activity using the ppH and also FRAP. The characteristic of the extract from two different solvents, ethanol and water. as shown in the table. So both extracts were compared between their physical properties and also the chemical properties. Okay, from the table, you can conclude that the use of different solvent resulted in the variation of color, odor, and also the extraction yield. The variation is due to the nature and amount of the secondary metabolite extracted. However, the both extracts are in the gel type of extract. The extraction of AVBL using ethanol give resulted in green in color, while distilled water result in the orange to brown in color. Okay, the extraction yield of distilled water as a solvent gives high extraction yield compared to ethanol, which is 11.231% to 5.358%. So this result illustrated that the extraction yield increased with the increase in polarity of the solvent. Distilled water has higher polarity compared to ethanol, which is 10.2 to 4.3. So, during the extraction, compounds other than phenolics such as proteins and carbohydrate may have been extracted, thus resulted to the extraction higher extraction percentage yield. Besides that, proteins and carbohydrates and also soluble in water than in ethanol. These two charts shows the comparison between the total phenolic and also the total flavonoid contents of two different solvents. From this chart, it is clearly seen that AVBE shows the high result compared to AVBW. This is due to the content of more non-phenolic compounds such as carbohydrate and terpene in water extract than in ethanolic extract. The difference can be explained by the variance of the solvent's polarity that selectively extract the various hydrophobic or hydrophilic phenolic compounds from the sample. Besides that, ethanol as a solvent also is a polar molecule because it has a hydroxyl group. It also hides the electronegativity of oxygen, which allow the hydrogen bond to take place with other molecule. The ethyl group in ethanol is nonpolar and also the hydroxyl group is the polar. So, ethanol can be dissolved in both polar and non-polar substance. The graph shows that the scavenging activity of plant extract using DPPH. From this graph, we can see that AVBE shows high scavenging activity compared to AVBW. Besides that, visually, we also can see the discoloration of DPPH from purple to yellow if there is antioxidant. In this study, ABBL extract able to change the color of DPPH from purple to yellow. The change in color also indicate that the antioxidant in this extract were capable of scavenge free radicals and reducing oxidant. Apart from that, the antioxidant performance of DPPH was calculated using IC50 value. IC50 value was calculated to determine the concentration of the sample required to inhibit 50% of radical. The lower the IC50 value, the higher the antioxidant activity of the sample. So in this study, ABBE shows the lowest value of IC50 compared to ABBW. Thus, we can conclude that ABBE is a strong antioxidant compared to ABBW. Another task to test the antioxidant activity by using the FRAP. So, from the bar chart, we can conclude that the ABBE shows the higher result compared to ABBW. This is because the variation of bioactive group extracted by the different solvent. So each bioactive group contributed with a different antioxidant power, as this group were found to have different correlation with antioxidant capacity. Besides that, the FRP also can visually seen by the change its color from brown to the blue. This is due to the reduction of ferric Fe3 plus to form ferrous Fe2 plus if there is antioxidant. So this plant extract able to reduce the color, to change the color and reduce the Fe3 plus to Fe2 plus form. In conclusion, the table shows the comparison of two types of solvent with the result of TPC. TFC, and also the antioxidant activity. Even though the extraction yield of distilled water is high compared to ethanol, however, the result of TPC, TFC, and also the antioxidant activity performance of AVBE is high compared to AVBW. Besides that, the findings also illustrated that there is a strong correlation between TPC, TFC with antioxidant activity. From this finding, it is concluded that the AVBE is the best solvent to extract this plant extract. It is because it has high TPC value, TFC value, and also high performance of antioxidant activity. This plant extract also has potential as natural antioxidant. Attached is the sum of the list of references that are used in this study.